For our next session, I'm happy to welcome Ashish, who is the CTO and co-founder of CloudFuse, where he leads the vision and engineering behind a cutting-edge observability data lake that unifies logs, metrics, APM, and infrastructure observability. With a proven track record as both a technologist and entrepreneur, Ashish previously served as chief architect and co-founder at CloudFuse, shaping the company's core platform from the ground up. Before CloudFuse, Ashish was principal engineer and management architect for the HyperFlex product line at SpringPath, which was later acquired by Cisco, where he played a pivotal role in delivering next-gen infrastructure solutions. Earlier in his career, he was a staff engineer at VMware, contributing to flagship products such as vCenter Server and Virtual Desktop. Ashish's expertise spans cloud-native architectures, large-scale distributed systems, and observability platforms. He is passionate about empowering teams to build reliable, scalable systems and is recognized for his ability to build deep technical insights with practical business impact. At KCD Bangalore, Ashish will share his journey and lessons learned from building unified observability platforms offering actionable insights for practitioners and leaders in the Kubernetes and cloud-native ecosystem. We welcome you on stage, Ashish.
Thank you very much for the warm introduction, and very glad to be here in Bangalore. I started my career here at Bangalore, so this city is very dear to my heart, and I always like to return here every once in a while. I'm Ashish Hanwadikar. I'm CTO and a co-founder at CloudFuse. CloudFuse is a unified observability platform designed for cloud-native and Kubernetes workflow, and it's designed to run on-premise on your VPC so that you don't pay very high ingress cost, and you can actually manage the deployment yourself. This is something a cross between open source and the SaaS observability products. Today I'm going to talk about how do we apply the observability to the modern AI applications. So as some of the speakers previously described their AI journey, we have two classes of AI applications. One is basically the standard AI application that most people are familiar with, basically like a ChatGPT kind of interface, where you ask some questions, you attach some context, some documents, and you ask it to summarize those documents, or maybe write a poem for you or write code for you. And that's a very common set of applications. Another set of applications is agentic workflows, where you basically set the goal for the agent, and the agent will march towards that goal by iterating through various scenarios and getting input from the users and talking to the LLM model and adjusting its inferencing to reach the goal. So for both class of AI application, there are some fundamental components. Obviously, the biggest and most important component is the large language models, like ChatGPT, GPT-4, O3 Mini, and stuff like that. They are based on the transformer architecture, and they are the key components. But to make them work, you need to request the right kind of information from those LLM model through a combination of the user-provided input, like question or a set of instructions. And you have to combine them with the local context, like such as your Google Docs or local file system, or any, if you're writing code, you have to present some of your local code from the GitHub repository or something like that. Along with these prompts, the local data that is basically passed to the LLM, it depends on complexity. You could use MCP servers, for example, to pull data from Slack or GitHub, or you could use vector databases, which deals with the unstructured text. Obviously, to run all of that, you need a complex infrastructure. So this is where the Kubernetes and cloud infrastructure come into play. So observability, why this is observability important for AI applications? One of the key reasons AI models perform so well, because they provide non-deterministic output. So between different runs, they can generate different output. And at the time of the when you make the request to the LLM models, if you don't capture all the input, context, or output, you cannot get back to the original data ever. So you don't know what exactly happened when something goes wrong. Imagine your chat application gave wrong information or gave a toxic output or hallucinated. Only way to figure it out is to go back and look at all the data that you presented and output it generated. So that's why the LLM Observability is very special. And as we know, LLM applications are pretty costly. So we have to monitor the cost and usage very tightly. I will skip this slide for the sake of, in the interest of time. Let's go straight to the LLM Observability. So what does LLM Observability involves? Like I mentioned, you need to capture all the spans and traces about the interaction with your LLM model. Otherwise, you cannot troubleshoot any further. In addition to that, since you have all the data that is captured, now you can actually sort of replay all the interaction you had with the LLM model. And one way to actually do that is use evaluations, where you take that data, pass it to another LLM as a judge, non-production LLM, and that actually analyzes the relation between input, context, and output, and tries to give you a score. Is your application hallucinating more often? Is it costly? Is it giving relevant answers and stuff like that? And you can also do pretty interesting exploration on the embeddings, which I will show you through some of the screenshots. I guess the screenshots were not included for some reason here. But basically, embedded exploration allows you to group and cluster all your inputs and output and see as a cloud of points. And you can actually see if there are certain inputs or outputs or context that are outlier, and that might be causing you higher cost, or they might be causing you hallucinations, or it might be causing irrelevant answer or toxic answers. And that allows you to basically troubleshoot your LLM application and fine-tune. And typically use things like prompt templates. You can also change the way local databases are queried, and you can use different embedding schemes and stuff like that. So that is the basically purpose for embedding exploration. So that's it from my side. Thank you for joining my talk. It was great, again, a pleasure to visit Bangalore. We have a booth, please visit us. And we also have a breakout session along with Sapnil, and I will be presenting a breakout section on how to build an observability data lake for unified observability. Thanks a lot.